Yeah, welcome everyone. I'm Dennis Kuppens from Zeus MicroTec. Today we're going to talk about enabling innovation. Me myself, I'm product manager of Inkjet at Zeus. Today we will have a short company introduction, introduce the LP50 inkjet printer a little bit, but most of the time I will spend on 4 applications that we have been developing, but also our customers have been developing. So this is our company vision. So we want to enable innovative in the semiconductor advanced back-end photomask, but of course also a lot more. So today is not only about semiconductors, but who is this MicroTec? For the people who don't know the company, we are a German-based company. A lot of systems in the field for a long time. Last year we did $420 million, 420 million euro order intake, and about 1,200 employees worldwide. Most of our revenue comes from sales, so high volume production in the semiconductor industry back end, but of course also Europe and Americas, where a lot of the more newer developments take place, right? SUSE as a company, it's a long history, has several technologies, coating, photomask, bonding, which is huge at the moment. So the bonders are being used to produce the AI chips, which is exploding at the moment. It's really popular. But in the long history, I want to point out that in 2020, they bought us, the Pixel department where I'm from, in Eindhoven, for the digital inkjet coating technology. So next to spin coating, spray coating, also inkjet coating. We're not new at Pixel inkjet. So if we dive in that a little bit more, after I've shown you this, so 75 years we celebrate this year. So long history, but Pixel also has a history a little bit shorter, but already started 2007 with the introduction of the LP50 inkjet printer. And since then, we have been doing a lot of big projects. But the key thing is that this small inkjet printer that we have brought today with us here has been enabling all these developments, right? And not only for us, but also for other people. So at this moment, this little machine, there's 400 plus machines in the world, everywhere, I would say, universities, startups, major tech companies. And very importantly, there are a lot of publications where this machine is being used. So if you want to see them, go to the website lp50.sus.com, scroll down halfway, there's a button for Google Scholar, click on that, and perhaps you will find some publication which is in your field of expertise. And it's being used in so many different markets than just semiconductor. So it's impossible to name all of them. So I just came up with the number 50, but perhaps it's more, perhaps less. Right, but then the more interesting part. So how does SUSE enable innovation, right? What do we do that? How do we do that internally, and how do we enable other people to do that? So this is a really exciting one. Waveguides in augmented reality. So we're talking about glasses, which projects an image into your eye, which then allows you to see something that the one who is in front of you doesn't see, or projects like a movie or information. You know what it is. But how does that work? Well, there are many components, of course, in such glasses. You have some kind of projection device, which outputs an image, but that image has to end up in your eye. And there are things that are called input grating, redirectional grating, and output grating. And they're called waveguides. So the light waves have to be guided